Today we're going to talk about specific heat. Specific heat. Review from last time, temperature and thermal energy, not quite the same thing. To show you this, we can look at our picture of the two beakers of water. Now, if you notice, the temperature is the same, 100 degrees Celsius for each beaker of water. So the temperature is the same, however, the thermal energy is not the same. Which of these would have the greater thermal energy? Of course, it's beaker B, because beaker B has twice the amount of water, 1,000 milliliters, versus beaker A that has 500. So beaker B has the same temperature, but double the thermal energy. Okay, now specific heat. By definition, it's the amount of heat required to raise the temperature of 1 kilogram of a material by 1 Kelvin. You'll see that on Quizlet and Quiz. And what that specifically means is that items with high specific heat transfer heat very slowly. For example, water has a high specific heat. And on the other hand, low specific heat means that those materials transfer heat very fast, very quick. For example, metal. Here's a chart. You would never have to memorize these, but you can just look off of this chart and you can see that water, alcohol, ice, they have very high specific heats, transfer heat very slowly. And then aluminum or aluminium, all the way down to copper, they all have very low specific heats, meaning they would transfer heat very fast. Here's another chart. You can find these charts on the internet. Okay, so specific heat. You can see the chart there, at least part of the chart. You can see that ice has very high specific heat compared to the others on the chart. Also, water at the bottom has high specific heat, which means it would transfer heat very slowly. So what does this all mean? It's the heat needed to raise 1 kilogram by 1 Kelvin. You can look at the chart there, comparing water, sand, and Fe, iron. So we use this to explain why materials react differently when energy is added to them. So a material with large specific heat will cool down slowly. For example, water. And materials with small or low specific heats will cool very fast, like metals. Okay, here is a demo I want to show you. This demo was done with time-lapse photography. The demo lasted 3 minutes, but it's going to only last for 30 seconds on the time lapse. This was done in my kitchen under normal conditions. Room temperature was 70. I didn't add any heat. All I did was take an ice cube and set it on the wood. I took a second ice cube, set it on this brick of aluminum, and I just let the time go, and you'll see how this shows the specific heats. Let me play the video here. This is on my YouTube channel, so remember to subscribe to Coach Wieand. Okay, you can see that heat's being transferred very fast through the aluminum, low specific heat. You can see that this ice cube is not melting at all. So heat's being transferred very slowly. High specific heat for the wood. Again, this was not, no heating was involved. This was just the air, the normal air heating it up. And you can see that at the end, after about 3 minutes, the ice cube is all gone. All the heat transferred through this very quickly, low specific heat. Oop, Sneezing Panda, Elvin's Toothpaste, Hallway Surfing. You got to check out CoachWieand.com when this video is over, not right now. Okay, let's go on to the next slide here. Okay, so something you can try at home is take ice cubes and set one ice cube on a variety of different materials. And you can let a few minutes go by and see which ice cubes melt the fastest. And again, if they melt fast, then that substance would have low specific heat. Another experiment you could try, and this will be done actually in high school physics when you compare different metals using a calorimeter, which we don't have those in the kitchen. They're all at school right now, so we can't show you that. But you can always Google that if you want to check it out. Here's a picture of specific heats, comparing soil versus water. Again, these are more calculations for high school, not middle school, but you can take a look at those. Here's a graph here showing water, sand, and iron. You can see that according to the graph, one of the materials requires more heat to raise the temperature by 1 Kelvin. Okay, just a little review here, comparing and contrasting. Temperature, average kinetic energy, thermal, total energy, and heat, which we're about to get to, is transferred. So thank you for the screencast and for listening to the screencast, I should say. We'll be back next time with a screencast on heat transfer. That's conduction, convection, radiation. Have a great day. We'll talk to you soon.